Hi, in this session, we shall deal with problems of ILD for simply supported beam with system of loads. Determine the maximum bending moment which can occur when several loads of 40, 80, 12 and 80 kN are acting and are separated by a distance of 3 meter, 2 meter and 2 meter crosses a span of 40 meter. We are asked to find the maximum bending moment. Several loads of 40, 80, 12 and 80 kN separated by distance of 3 meter, 2 meter and 2 meter crosses a span of 40 meters. Here we are not given the position of section, that is we are not aware of Z. In such kind of problems, this is the procedure to be followed. In the first step, find out the total reaction R. R is the sum of all loads. So here R is 40 plus 80 plus 12 plus 80, which is 212 kilonewton. Now in the second step, we need to find out the value of X. That is, the reaction R which we found out in step number 1 is at a distance X from the first load. To find out X, we have to take moment above the first load, that is R into X is equal to 80 into 3 plus 12 into 5 plus 80 into 7. That is X is equal to 4.06 meter. Now we have to place a load at the section. So here is a 4-load system. We can neglect the loads at the end and consider the loads in the middle. So here we are neglecting 40 and 80 kilonewton and considering 80 kilonewton and 12 kilonewton. Now in the third step, we are considering this 12 kilonewton. We are placing the 12 kilonewton at the section. Draw the section along 12 kilonewton, extend the section line. We shall draw the ILD for bending moment. Now 40, 80 and 12 kilonewton, 3 and 2 meter distance. Section is along 12. X distance is 4.06 meter. The remaining distance from X to the section is D. D is 5 minus 4.06, which is 0.94. Find out the half of D, which is 0.47. Now to find out the distance of section Z, we have to use the equation h by 2 plus d by 2, where h is span. 40 by 2 plus d by 2, that is 20.47 meter. That is, the section Z is at a distance of 20.47, that is that 12 kilonewton is up to a distance of 20.47 meter from A. Mark the distance. Now bending moment can be written as 40 into M1 plus 80 into M2 plus 12 into Z by L into L minus Z plus 80 into M3. M1, M2, M3 can be solved using similar triangles. And the value of bending moment comes out to be 1859.08 kilonewton meter. Now we are placing the other load, 80 kilonewton at the section. That is, among the 2 loads considered, we are taking the other load. So we are going to draw the section along 80 kilonewton. Again draw the ILD for bending moment. Follow the same procedure. Draw the section along 80 kilonewton, mark X, find out the distance D, which is 3 minus 4.06 meter in this figure. That is minus 1.06 meter. Find out D by 2, which is minus 0.53. Find the value of Z, which is h by 2 plus d by 2, where h is the span. It comes out to be 19.47 meter. Now mark this Z value in the ILD diagram, that is from the left end to the second load Z is 19.47 meter. Now the equation for bending moment can be written as 40 into M1 plus 80 into Z by L into L minus Z plus 12 into M2 plus 80 into M3, and this comes out to be 1888.52 kilonewton meter. Now we are asked to find out the maximum bending moment. Compare which is the maximum bending moment, and we find out that the maximum bending moment is 1888.52 kilonewton meter at a distance of Z is equal to 19.47 when 80 kilonewton load is placed at the section. Thank you.